Okay, hello everybody. This is Parabolas Day 2 here, and if you have some graph paper with you, or you want to grab some from up in the front of the room, feel free to do that. If you were not here yesterday, Parabolas Day 1, we learned how to sketch parabolas when the vertex was at 0, 0. So we're going to get a little bit more practice with that today. And then beyond that, we're going to talk about how do we work backwards. So given some information about a parabola, how do we come up with its equation? And then we're going to move away from a vertex at 0, 0 today and talk about what if the vertex is somewhere else in the coordinate plane? How would we possibly come up with what a sketch looks like based on some slightly different looking equations? So again, if you weren't here yesterday, or even just as a quick recap, if you were here, some quick sketching practice. Let's sketch the parabola x squared equals negative 12y. So again, based on yesterday, we saw that this sort of standard form tells us that the vertex is at 0, 0. And then one of the important values that we need to determine to get to different points on the parabola is based on that coefficient of y on the other side. So we set that equal to the quantity 4a. So 4a equals negative 12. We know that a is negative 3. And that value of a gets you to some other points on the parabola, including the focus. And then beyond the focus, we also talk about endpoints of the lattice rectum and things of that nature. One other thing that I think is worth mentioning here is that since it's an x squared equation and the value of a is negative, this particular parabola opens down. All right, so a sketch off to the side would look something like the following. Oh boy, that wasn't very good. Let's try that again. All right, okay, that's slightly better. Okay. Since I know it's opening down, maybe I'll make my x-axis pretty high there, so we have vertex right at the origin there. And when the parabola opens down, what we do is go down 1, 2, 3, and label that point as F. That's where the focus is located. And then to get how wide the parabola opens, that would be the endpoints of the LR. Remember, the LR has a total length here of 12. It's the absolute value of that 4a value. So if I cut that in half, that's how far to each end of the parabola from the focus we should go. So if you go 6 to the right, and then you go 6 to the left, if we connect those points back to the vertex, it's a really decent sketch of what this parabola should look like. And the other additional thing I'd like you to include is that every point on this parabola, based on the definition from yesterday, is equidistant from the focus and the line that's called the directrix. So if we went a distance of a units down to get to the focus, go that same distance above the vertex to get to this line up here, which we know is called the directrix. So the directrix has the equation y equals 3 in this case. Just for labeling purposes, that eventually on a quiz you'd be asked to identify some special coordinates. So the focus has the coordinate 0, negative 3. And if I ask you for the endpoints of the LR, those endpoints are at 6, negative 3, and also negative 6, negative 3. Okay. So that's a good example of a parabola that opens down. And again, x squared implies that the parabola will open up or down. Let's practice with an equation of a parabola that opens in a different way. So on the other hand, if I gave you the equation y squared equals 8x, go ahead and take the next 2 minutes and make a sketch in your notes of y squared equals 8x. I will ask for a volunteer to come up and hit pause. This way you can take 2 minutes to do that. Okay, time yourself for 2 minutes, hit pause, come back, and you'll see what this graph looks like. Okay, so we're back. Hopefully in that time frame, you determine that this is a parabola that opens to the right. And the value of a in this case should be 2, because 4a is 8. So based on all this information, if I were to draw a set of axes over here, the vertex is 0, 0. If you go 2 to the right, that's where the focus should be. So the focus has the coordinate 2, 0. And based on the lattice rectum having a total length of 8, if you go up 4, 2, 3, 4, and down 4 from the focus, those are the ends of the LR. So those would be the coordinates to -4 and then also to +4. And the last thing I would like you to include, like we did before, is where the directrix is. So again, put 2 to the right to get to the focus, go 2 to the left to graph the directrix line. Since it is a vertical line, the directrix equation in this specific example is x equals -2. And graphing these two examples to get started today will help us for what we get into right now, which is going to be a little bit of working backwards. Okay, we're used to kind of working backwards with things in general. We did it with circles, given some information about a circle. Can we come up with this equation? We're going to do the same thing right now with parabolas. So if I gave you that the vertex of a parabola is at 0, 0, and the focus is at 3, 0, we're going to determine the equation based on those two pieces of information. Now, what I'll say here is that it's certainly not a requirement that you then graph the parabola as a result of that information. However, I think it is nice to see as a sketch over here kind of what that information is. So if I plot the vertex at 0, 0, and then I go up 3 to where the focus is, just based on plotting those, oops, whoa, that was really bad. You're probably yelling at the screen right now. Let's try that again. All right, so let's come over here to 0, 0. How about 3, 0 to the right? There we are. Okay. So if I plot that correctly, then we can clearly see that this parabola has to open up to the right. I don't know if I said this at all yesterday, but I like to think of the parabola as eating the focus. It's like a little Pac-Man guy here. So if we think of it in that way, we know that it's going to open up to the right, which tells me the equation has to have y squared in it when it opens to the right. And then the last thing I really have to determine is if it's a y squared equation, what that coefficient is in front of x, which we know is 4a, and a is the distance from vertex to focus. So if a is 3 in this case, the equation of this parabola that opens up to the right is y squared equals 12x. So the nice thing about at least the examples we do today is that I actually will give you all these examples with a vertex at 0, 0. Tomorrow we'll extend this a little bit further and move the vertex somewhere else when we work backwards. But as a second example here, if the vertex is 0, 0, and the directrix is the line y equals 2. Based on that information, again, what you can do quickly off to the side here is plot that vertex at 0, 0. And if I draw the line y equals 2, just don't forget in this case y equals 2 is a horizontal line. So based on that, the distance from the vertex to that directrix, I know that a is 2 units there. And in fact, since I know that the parabola opens in the opposite direction of where that directrix is going, this is going to open down. So when we have a parabola that opens down, I know this is an x squared equation. I know the value of a, just be careful, is that when it opens down, technically we usually list a as being a negative value. So a we might want to call -2 in this case. So given that a is -2, x squared would equal 4 times a, which is -8y. So given this information, I would imagine that some of you can do this without making a sketch off to the side. You know, I think it becomes maybe a little bit tougher when we move away from a vertex at 0, 0, but hopefully we're good to go there. All right, let's just do a couple more of these. So in number 3, I'll tell you that, again, vertex is 0, 0. The length of the lattice rectum in the LR is 10, and that this opens to the left. So based on this information here, okay, again, vertex we knew is going to be at 0, 0. If the parabola opens left, we know that the equation in general is y squared equals 4ax. And the thing is, without actually even sketching any of this here, I think this is almost a good example to show you, maybe what we can think about without sketching. This already is the value of 4a. the total length of the LR is equal to a 4a. So I'm just going to plug in 10 to the equation and get y squared equals 10x. However, the last thing you have to really keep track of is if I'm opening left as opposed to opening right, we know that 4a in the equation should be negative. So you should have for this one y squared equals negative 10x. It's a pretty easy substitution. However, just don't forget that we're paying attention to, based on the way it opens, 4a sometimes is positive and sometimes it is negative. All right, last one. If I give you a vertex of 0, 0, and I tell you that the parabola has x-axis symmetry, and that it passes through the points negative 3, 6. We're going to write an equation based on that criteria. Okay, so given that information here, again, if you want to plot the point negative 3, 6 and have kind of a rough sketch off to the side, we know the vertex is here. I'm just going to really quickly estimate. I'm going to call that negative 3, 6 up there. I realize it doesn't really look like negative 3, 6 according to my grid. But if that's the point negative 3, 6, why did I make my parabola open to the left instead of, let's say, going through that point and opening up this way? Okay. So I'll tell you, I know that my graph is blue and not red in this case because it has x-axis symmetry. So if you take a quick look over here, if it has x-axis symmetry, it has to be opening up to the side, so it's going to open left. So when something opens left, we know it's y squared equals 4ax. And the thing is that in certain cases, this point will be an end of the LR, but we can't assume that, okay? So we're actually maybe not sure if it is an endpoint of the LR right away, but to get around that, all we're going to do to find 4a in this case, because that's the last thing I have to figure out, is you're going to plug in the coordinate of the point for y and x, which is something we're used to, right? So if I plug in 6 for y, and I plug in negative 3 for x, remember what I want to isolate here is I want to figure out what does 4a equal. So you get 36. It's 4a times negative 3. And then dividing that negative 3 over gives you that 4a is negative 12. Okay. And that's pretty much it. So if I know that 4a equals negative 12, I can come back and say the equation is y squared equals negative 12x. Notice how the value of 4a came out to be negative, which it should because it's opening up to the left. And in the end, I'll tell you that point does wind up being an end of the lattice rectum, but it did not have to be one. So in any case, when I tell you it passes through a specific point, start off with the general equation right here, and then plug in the point for x and y and find the value of 4a from there. Okay. So if we're okay with kind of some working backwards concepts, let's go ahead and talk about how do we sketch parabolas whose vertex is somewhere else other than the origin. So we're going to talk about graphing with a vertex at h. Okay. So based on the forms that we already know for vertex at 0, 0, I don't think it will be too surprising to see that a parabola that opens up and down, the equation would be x minus h squared equals 4a times y minus k. Okay, so the x quantity is the one that's squared, and we account for this new vertex at h and k. This is going to be a parabola that opens up or down, and of course that depends on if a is positive or if a is negative. And you actually saw this form last year in Algebra 2. So this shouldn't be too new for you, but it's been a while since we've done it. All right, on the other hand, we would have y minus k squared. Notice, by the way, how k is staying with the y values. Equals 4a times x minus h. So when you list the value of the vertex here, you always go h comma k. Notice how the h is going to be connected to the x term always. So we know this is going to be a parabola that either opens up to the right or to the left, depending on the value of a. If a is positive, we open up to the right. And if a is negative, we open up to the left. Okay. So based on that, let's go ahead and take a look at our first sketch here. So the first example will be x minus 2 squared equals negative 4 times y minus 3. If at any point I'm going too fast, by the way, go ahead and pause for a second so everyone can get caught up. And additionally, this will be posted on the website later, so certainly go back and check this out on the website if needed. All right, in this example, first thing I would expect you to be able to identify is the vertex. Vertex has coordinates 2, 3, according to the values of h and k in the new standard form of a parabola. The value of a in this case, if 4a equals the quantity negative 4, a is negative 1. So knowing that a is negative and that the x terms are the one that are being squared, we should know that this is a parabola that opens down. Okay, so that's kind of an important piece of information. And once I've identified those pieces, that really is enough to start a decent sketch here. So if I need a vertex at 2, 3, you could definitely take that into account wherever you draw your axes. So if I move them over to the left and down a little bit, the point 2, 3 is right here for me. And if I know this opens down, to get to the focus, I have to go down 1 unit. Okay, so that's the focus right there. Since the LR has a total length of 4, if we cut that in half, we're going to go to the right 2 and to the left 2 to get to the ends of the LR. And that, we know, is pretty much it in terms of needing to make a sketch of the parabola. Hopefully you're not forgetting to include where the directrix is. So the directrix would be 1 unit above the vertex. And the last thing I want you to do after you actually graph all of that is list some of that other critical information. So we know the vertex is at 2, 3, but in this case the focus is 1 below that at 2, 2. So list that off to the side. Focus is at 2, 2. We know that the directrix line has the equation, it's 1 above the vertex, so y equals 4, horizontal line right above it. And I'm not sure if I listed them in this way, but I like to list the ends of the LR as E and E prime, so you might see me do that in the future. So those coordinates can be written as E would be in this case 0, 2, and then E prime would be 4, 2. If you don't list them using that specific notation, that's fine, but that could be something that we wind up getting used to. Okay. Okay, let's try another example here where we have to do just a little bit of work to get it into standard form first. So for number 2, we'll do y squared plus 8x plus 8 equals 0. So that doesn't quite look like the standard form that we saw just a moment ago, so we have to do just some quick steps to maybe isolate the y squared term. If there were any other y terms, I would have kept it on the same side as the y squared, but the 8x and the 8, I'm going to subtract those to the other side. And then there's really just one more step to get this to look like standard form. It would be factoring out the coefficient of x. Okay, so that coefficient of x is negative 8. We have to take that out as a GCF. Regardless, by the way, even if it goes in nicely to the other term, I mean, in this case, it does go in nicely. Just be careful that when you take out negative 8 from negative 8, now you have x plus 1 as a quantity left over. So that is now a standard form that maybe looks a little bit different than how we wrote it a second ago. If you would want to write this as like y minus 0 squared to help you visualize what's happening there, that's fine. Certainly not a requirement. But in this form, I can clearly identify that the vertex has the coordinate negative 1, 0. So just be really careful with that, that when it's x plus 1 over here on this side, and there's a bell, not your bell, do not leave that. Okay, negative 1, 0 is the vertex. Again, make sure you get the x value of the vertex from where the x's are, the y value from the y coordinate. So if the vertex is negative 1, 0, the value of a in this case is going to be negative 2. And I know that this particular parabola opens to the, hopefully you all said left, y squared, and if a is negative means we open up to the left. So the vertex is negative 1, 0. So let's come over here for a sec. Oh boy. For a little, smartboard's not oriented. Let's stick stick with me for a sec. Alright, let's try this. Okay, so we got -1s here for the vertex. It's going to go 2 to the left to get to the focus. If the value of A is 2, we go, and the LR is 8, we go up 1, 2, 3, 4, and down 1, 2, 3, 4. Okay. So those are where the ends of the LR are located, and then I go to the right 2 to get to the directrix, which is this line right here. And the last thing I want you to do is write all that important information down. So the focus had the coordinate 2 to the left, -3, 0. I'm going to get fancy on you for a second here, and I'm going to write the coordinates of the ends of the LR all at once. Because from that focus at -3, 0, I went up and down 4. So how you can express that is you can say -3, and then from 0 we went up 4 and down 4. So that can be written in kind of a combined form as +or -4. If you're not comfortable with that, certainly you can just write them separated. But the directrix is the last thing over there. The directrix is the equation x equals, because it's vertical, and in this case it would be x equals 1. Okay. Let's see if we can do maybe just one more example where we do a little bit more to get something into standard form, and of course we'll practice with this more tomorrow on our 3rd day of parabolas. So let's take a look at something like number 3. We'll do y squared minus 4y plus 8x minus 28 equals 0. So for this particular example, this will be the most involved in terms of algebra that we have to do to get this into standard form. The very first thing you would do is group the y's together. And since the y is the squared term, I'm going to leave those on the left side. Anything that doesn't have to do with the y, which is the 8x and the minus 28, move it to the other side appropriately. So here we get -8x and then plus 28 on the other side. Okay. So from there, how am I going to get this into standard form? Well, very much like what we do with circles, we're going to complete the square. Okay, so for the y's, you don't have to do it once though, because there's only one squared variable here. We have to figure out what do we do to complete the square for the y's here. So if I take -4 divided by 2 and square it, the value that completes the square is +4 on both sides. So the left side turns into y minus 2 squared. And the right side becomes -8x plus, well, 28 and 4 combined to give you 32. And the very last thing you should do here is, just like we did in the last example, whatever that coefficient of x is, you have to factor that out as a GCF to get this to look like standard form. So if I take out -8, I'm left with x. And then from the positive 32, you should really write -4 there. If you want to double check that quick in your head, distribute that -8 back in to confirm, yes, you will get positive 32. Okay. Think carefully about the vertex here. Maybe 10 seconds to write down the vertex. So I'm really hoping you wrote down the coordinate 4, 2. It's very common to look at that and say 2, 4. But remember, the x value for the vertex has to come from where the x's are. A in this example is -2 again, and actually this is another one that opens left, similar to the last one we just sketched. So it should have some similar properties, except for moving the vertex pretty far away from 0, 0. We're now at 4, 2. Okay. So I might draw my axes to look something like this. There's my vertex. Oops, that's a little too far out. Let me try 4, 2. So 4, 2 is right here. Okay, if it opens to the left and A is -2, we're going to go 2 to the left there and put the focus. If you want to write that coordinate down now, we might as well, but the focus is the point 2, 2. The length of the LR is 8, so for the focus we have to go up 1, 2, 3, 4, and then down 4 as well. Connect those points back to the vertex. Okay. And again, if I get a little fancy for the endpoints of the LR, what are we doing here? E and E prime would be 2, comma. From the y value of 2, I went up and down 4. So that's how you can write that. From the y value of 2, we added 4 and subtracted 4. So if you want to separate that, it's just 2 comma 6 and 2 comma negative 2. That's fine with me. Last thing I have to do is get that directrix line in there. So if I get 2 to the right, this line over here, which is the line x equals, that should be x equals 6, right? So the directrix is the line x equals 6. So I think that this should be enough to get you through tonight's homework. If you have any questions, certainly we will go over them tomorrow before we head into some more day 3 practice. Have a great rest of the day. I'll catch up with you tomorrow.